In my video on data and data types, we looked at the different types of data. One of those was numerical data. In this video, we'll look at displaying both discrete and continuous numerical data in a stem plot, otherwise known as a stem and leaf plot. This falls under the organise and display data step in the statistical investigation process. Specifically in this video, we'll look at a reminder of what numerical data is. We'll look at displaying numerical data in both a stem and leaf plot and a back-to-back stem and leaf plot. Finally, we'll have a quick look at skew or distribution of numerical data. So numerical variables are given in numerical or number form. The data collected is called numerical data. Discrete numerical data can be counted and takes on an exact number of values. Think of integers. Continuous numerical data represents measurements. These values can't be counted, can only be described using an interval or real number lines. Think of measurements. A stem and leaf plot, otherwise known as a stem plot, organises data into groups called stems so that the values within each group, called the leaves, branch out from the row. A stem and leaf plot is commonly used to display a single set of data or two related sets of data. They help to show how this data is distributed like a histogram or column graph, but retain all the individual data elements so no detail is lost. The median and mode, which we'll cover in a future video, can still easily be read from a stem and leaf plot because all the data sits in order. A stem and leaf plot is used when there's many different data values and it isn't practical to use a column graph or a dot plot to display the data. Instead, we use the stem and leaf. I'm going to use the same example from my displaying discrete numerical data video where a training firm investigated their attendance at the day courses versus the night courses. If you've seen that video, remember they randomly selected 10% of the attendance data from both the day classes and the night classes for 1 week. By dividing up the day and night classes attendance, they've stratified their sample. We looked at what was some of the ways they could summarise or display that data. Today we'll look at the stem and leaf plot. Here we have the data that was collected for the number of people attending the day training course. To construct a stem plot, it's usually easiest to first construct an unordered stem plot and then rewrite the leaves in ascending order to give the ordered stem plot. So we separate each observation into a stem, which is the first part of the number, and the leaf, which is the remaining part of the number. Write the stem in a vertical column, draw a line to the right of the stem, and write each leaf in a row to the right of the stem. I've written down the numbers listed above in order they are provided. Scale helps someone to read the stem and leaf plot. You notice from our data above, 18 is our first number. Therefore, we write 1 in the stem, and then 8 in the leaf. 17 was our second number, so I've written 1 in the stem, and then 7 in the leaf. Now we have an unordered stem and leaf plot. We rewrite the leaves in ascending order to give an ordered stem plot. This is what it looks like once the leaves part is rearranged. Now we can easily identify the smallest attendance, which was 16, and the largest attendance at the day training course, which was 42. So here we have the data that was collected for the number of people attending the training courses during the day and at night displayed in separate stem and leaf plots. We'd follow the process to create both stem and leaf plots individually, but we can improve on their presentation and comparability by creating a back-to-back stem and leaf plot. So a back-to-back stem and leaf plot can be used to compare two sets of data. The stem is drawn in the middle and the leaves on either side. The example here compares the number of people attending the night training course with the number of people attending the day training course. From the back-to-back stem and leaf plot, you can easily see that the number of people attending the night training course is much higher. However, there appears to be a much higher number of day courses, given we know that the sample was 10% of each. Interestingly, both the night and day courses have a similar smaller number of attendance, and they have a similar higher number of attendance. So the higher number of attendance was 42 for the day course and 41 for the night course. In a stem and leaf plot, symmetrical data will produce a graph which is symmetric around the center. So it would be symmetric on the left, day attendance around the 2. So you'd expect that column to be higher with that row to be higher with the row on top and the row below around the same length. The data in both these stem and leaf plots appears skewed in the opposite direction, and I've identified that with the green line. Finally, I wanted to show you a slightly different example. This time, I'm showing the heights of female students surveyed from a year level at school. Heights are continuous numerical data as they're measured. And they're displayed here in centimeters. In the previous example, we looked at numbers less than 100, so you'd only have one number in the stem. I'm providing this example to show you that you can have more than one number in the stem. This time we have hundreds and tens in the stem, therefore 11 in the stem and 8 in the leaf means the student was 118 centimeters tall, and you can tell that by the scale. Similar to the previous example, we can compare female data to male data in a back-to-back stem and leaf plot. Here, the smallest student surveyed was a female student. She was 118 centimeters tall. And the tallest student was a male student that was 149 centimeters tall. And that's taken from the last data point on the male side of the stem and leaf plot. So in summary, we've had to look at what numerical variables or data are, and we've looked at displaying numerical data in a stem and leaf plot and a back-to-back stem and leaf plot. And finally, we had a look at skew or distribution of discrete numerical data. Thank you.